we take an incident ray, and obviously this is the normal, that is, suppose the cross section, as you can see here, this is the cross section, this is the principal section of the prism. For these derivations, for doing these derivations, we are just taking the principal sections of the prism, that is ABC. Now this is the incident ray. As you can see here, the medium here is air, and obviously the prism, it is made up of glass. So when it enters from rarer to denser medium, you know it will move towards the normal. So this light ray, it should have passed, it should have gone in this direction, but as it is passing from air to glass, rarer to denser medium, it will move towards the normal. So this is the path of the light ray. This is our incident ray, so this will be our angle of incidence. We denote it by the symbol I1, and obviously this is our normal and this is the refracted ray. So this angle, it must be the angle R2. So this is I1, this is R2, and as you can see here, the light ray, again it strikes the surface. Again we draw the normal here. Here we have the normal, and when the light ray, it strikes this surface AC, then what will happen? You know that it has to travel from denser to rarer medium, that is from glass to air. So obviously it will move away from the normal. So it moves away from the normal, and this is the path of the emergent ray. You can call it the emergent ray, as we have discussed about it in the part that is about refraction through a parallel glass block or through rectangular glass block. So this is our emergent ray. I'll mention it here. Emergent ray. This was our incident ray. In general, we denote this one. This is our R1, and this angle R2. As you can see here, when this refracted ray, it strikes this surface, it has a tendency to come out, to move to air. So this will be our incident ray for the second time of refraction. When the light ray strikes surface AC, this will be assumed to be our incident ray. So this is incident ray and this is normal. So it must be our angle of incidence. I'll mention it here. R1, what is it? Angle of refraction. What is R2? Don't be confused. R2 is the angle of incidence. And why? You can see here. And what about this part? This is the emergent ray, or this is the refracted ray. So obviously this refracted ray, it will make an angle with the normal, and this is our angle of emergence. So I1 is the angle of incidence here, and I2 is the, I'll mention it here, I1 is the angle of incidence and I2 is the angle of emergence. Now this was the basic information that we have to use in the derivations. Now R1, R2, I1, I2, all of them are known to you. Now as you can see here, this light ray, if we produce it in this direction, in forward direction, then we can see that this light ray, it should have traveled along this path. This should have been the direction of incident ray, but the refracted ray, it is in this direction. It means that there is some deviation in the direction of light ray. This was the direction of incident ray, but the light ray, it deviates from its original path and finally it comes to this direction. It means that there is a deviation. Suppose we denote it with delta 1. Delta 1 here is the angle of deviation at the first, at the surface AB. So when the refraction takes place for the first time, this is our angle of deviation. And what about the angle of deviation which is produced when refraction takes place for the second time, that is at the surface AC. As you can see here, the light ray, I'll do the part for you so that there is no confusion. If you produce it, this ray in forward direction, then this should have been the original direction of the light ray, but it is not going so along this direction, it goes along this direction. It means that the light ray, it deviates from its original path by this much angle and comes along this direction. So this angle, it is our angle of deviation, that is delta 2. Now produce it in backward direction. Then as you can see, this line is a straight line and this line is also a straight line. I'll rub this part for now. We'll mention it later so that it is clear to you. This line, obviously it is produced, so it is a straight line, and this line, it is also produced, so it is also straight line. So what do we conclude? This angle, it must be equals to this angle. That is, if this is delta 2, then vertically opposite angle, this is also delta 2. We'll mention it here. This angle is delta 2. Now it must be very clear to you. I'll rub this part. This is at delta 2. How? Because these are vertically opposite angles, so this must be delta 2. Now I'll rub this part. Now again, let us mention it. This is our angle of emergence, that is I2. Now as you can see here, this is delta 1, that is the angle of deviation at the surface AB. What about delta 2? Delta 2, this should have been the direction of light ray, but it deviates by this much angle and comes along this path, that is along this direction. So this is our angle of deviation at the surface AC. So we have two angle of deviations. Now we can conclude the overall deviation, the overall angle of deviation. What is it? The light ray, it was traveling along this direction. So this is the direction of incident ray. And if we produce the emergent ray in backward direction, what do we conclude here? As you can see, here, this is the direction of incident ray, but the emergent ray, it is not along this direction. In fact, the emergent ray, it deviates. The light ray, it deviates from its original direction by this much angle and comes along this path, along this direction. So this angle delta, I'll mention it here. This is angle delta. It is the overall deviation because this is the emergent ray and this is our incident ray. So the total or overall angle of deviation is our delta. And as you can see, the delta here, angle delta here, if we look for this triangle, suppose I give it some name. This is our O, this is N, and this is P, this is Q. This point is O, this point is Q, this point is N, and this point is P. So if we look for the triangle OPQ, I'll mention it here. In triangle OPQ. So in triangle OPQ, these all parts, they are learned by you in the earlier classes in class 8th or 9th in mathematics. This is our exterior angle. So this angle delta, it must be equals to the sum of interior opposite angles, that is delta 1 plus delta 2. Now as you know about angle of deviation, now we can get to know about the factors affecting angle of deviation. The very first one is angle of incidence. With the change in angle of incidence, the angle of deviation of the given prism, of the given material, that is made of the given material, will also change. How will it change? I'll tell you. Initially, with the increase in angle of incidence, the angle of deviation decreases and attains a minimum value for a given, or we can write here, for a particular angle of incidence. Now, as you can see here, with the initially, at first, when the angle of incidence is increased, then the angle of deviation it decreases and attains a minimum value, that is known as angle of minimum deviation. It attains a minimum value for a particular, for a given value of angle of incidence. Now, if we increase the angle of incidence further, then the angle of incidence, with the increase in angle of incidence, the angle of deviation will also increase. I'll write it here. If we increase the angle of incidence further, then the angle of deviation, that is denoted by delta, angle delta, also increases. Now this is our basic condition. What it is, let us understand. If we increase the angle of incidence, at first, initially when we increase the angle of incidence, then the angle of deviation it decreases and it achieves a minimum value for a particular angle of incidence. We'll get to know about the certain conditions for the angle of deviation, such as we have a equilateral prism or a scalene prism or an isosceles prism. We'll get to know about it. But if we increase the angle of incidence further, beyond that range also, then the angle of deviation will also start to increase. We have, if we are asked to draw the graph, plot the graph for the angle of incidence and the angle of deviation, then the graph will be something like this. Along the x-axis, this is our x-axis and this is our y-axis. So along the x-axis, we plot the angle of incidence, and along the y-axis, we take the angle of incidence. So as you can see here, we'll take some points such as this point. For this point, the x coordinate is something, suppose it is I1, and the angle of deviation it is delta 1. So this is the coordinate for this point, that is I1 comma delta 1. As you can see here, whatever the value of angle of incidence is, the angle of deviation here is greater. But if we take the example of this point, then for this point, you can notice here that the angle of incidence, suppose that I2, the value here is I2. It's very clear to you that here I2 is greater than I1. The angle of incidence is increasing. And what do we observe here? If the angle of incidence is being increased here, then the angle of deviation, obviously for this point, the angle of deviation, suppose that this is delta 2. So obviously here delta 2 is less than delta 1. What do we observe here? When the angle of incidence is being increased, the angle of deviation is being decreased. Now suppose that we take this point. For this point, the coordinates are suppose this is I3, and for this value, this is our delta 3. This was delta 2. Obviously, you can see here that when the angle of incidence is increased from I1 to I2, then I2 to I3, the angle of deviation it was decreasing from delta 1 to delta 2, and then delta 2 to delta 3. So this is our angle of minimum deviation. Here delta 3, it is the angle of minimum deviation. If we keep on increasing the angle of incidence, such as if we talk about this point, now we increased, now I'll rub this part. if the angle of incidence it is increased further, suppose that this is I4 angle of incidence, then for this angle of incidence, what do we observe here? The angle of deviation it starts to increase again. Suppose this is delta 4. Now as you can see here, for I3 the delta 3, the angle of deviation was minimum here, but if we increase the angle of incidence further beyond this range, that is from I3 to I4, then what do we conclude? The angle of deviation it again starts to increase. Here delta 4 is greater than delta 3. So I think it must be very clear to you that initially when the angle of incidence is increased, then the angle of deviation was decreasing. But up to a certain minimum value, the angle of deviation will decrease up to a certain minimum value for a particular I. That is, here the particular angle of incidence is I3. But if we increase the angle of incidence further beyond this range, then the angle of deviation also starts to increase. I think it must be very clear to you. So this was the very first part, the very first factor that can affect the angle of deviation. Suppose that we have any type of prism, a scalene prism, an equilateral prism, or an isosceles prism. For any type of prism, we have a general condition. I'll write it here. In general, for the minimum deviation, angle I1 is equals to angle I2. It should be known to you. In the last video, I told you that this I1, what is it? It is the angle of incidence. And this I2, it is the angle of emergence. So, for the case of minimum deviation, such that the angle of deviation is minimum. So, the position of minimum deviation or the case of minimum deviation, what does it mean? That the angle of deviation is minimum. So, for the case, I'll mention it here. For the case of minimum deviation, angle I1 should be equals to I2. That is, angle of incidence should be equals to the angle of emergence. Or one more condition we have, R1 is equals to R2. I told you about this R1 and R2. This R1, what is it? I'll draw the figure here. This was our angle of incidence, that is I1, and this was our angle of emergence, that is I2, and this angle, that is R1, it was the angle of refraction for the first time of refraction, and when the light refracted for the second time, then this R2 was the angle of incidence. I'll mention it here. I already told you about this part. So this R2 here, it is the angle of incidence when refraction takes place at the second surface of the prism. So for this condition, the deviation will be minimum. Suppose that we are talking about the equilateral prism. It might be asked to you in your examinations that what is the condition for the equilateral prism if we want the condition of minimum deviation. That is, we are talking about the angle of minimum deviation. Suppose here we have the equilateral prism. Equilateral prism means obviously the angle of prism, that is A. This is our angle of prism. It should be 60 degree. So this I1, this is our R1, that is the angle of refraction, and we draw a normal here. So this was our incident ray, this is our refracted ray, and when this refracted ray it strikes the second surface, suppose it is BC. So when the refracted ray it strikes the surface AB, then the refraction takes place for the second time. Then here the R2 here will be our angle of incidence, and this I2 here it will be our angle of emergence. So if we talk about the condition of an equilateral prism, then for it the minimum deviation, in the case of minimum deviation, this I1 or I2, it is found experimentally that this I1 or I2 it should be equals to 48 degree. Now it might be possible then in the numerical part you will be given that the angle of incidence is 48 degree, and you have to find the angle of minimum deviation here, that is it is represented as minimum deviation. Angle of minimum deviation is represented as delta minimum. So we can find it here. How? I told you about the expression that we derived in the last video, that is angle I1 plus angle I2 is equals to angle delta plus angle, along with it the angle of prism. So we can find here the angle of minimum deviation. It can be found. How? I'll do it here. It's very simple. For finding the angle of minimum deviation, I told you that the angle of incidence and the angle of emergence, they should be equal. In any type of prism, it is the general condition. If we talk about equilateral prism or scaling prism or isosceles prism, it will be obeyed everywhere. But this is the particular condition for this condition, that is 48 degree. I1, I2 is equals to 48 degree. It is the particular condition for an equilateral triangle, equilateral prism only. So we know about this part. What can we write here? I1, I2 both are equal. So we can write over here twice angle I1 or twice angle I2 is equals to angle delta. And we know about the angle of prism also, that is 60 degree. So twice angle I1 or twice angle I2, it is 48 into 2, that is 96 degree. And this 60, it will be shifted on the right side, left side. Then we can find the angle of minimum deviation. So the angle of minimum deviation is 36 degree. So it might be possible that you are asked to find the angle of minimum deviation in the case of an equilateral prism. So this was about the equilateral prism. And one more part, the refracted ray. In the case of the equilateral prism, the refracted ray inside the prism will be parallel to the base of the prism. Obviously you can see here DC here is the base of the prism, and the refracted ray that is inside the prism, it is parallel to the base of the equilateral prism. So these conditions, they were particularly for the equilateral prism. Now you might think that, sir, how can we change the angle of incidence? Obviously we do not have any control on light. We cannot control the positions of the incident ray. It is independent. We cannot control the light. We cannot control the incident ray. But obviously we can change the position of the prism. Suppose I have a prism here, then some incident ray, some light ray is striking this surface AB or AC. Then what can I do? I cannot control this incident ray, but I can change the position of the prism. Suppose this incident ray, it strikes the surface at this position. Then if I change the position of the prism, then the angle of incidence will be changed. It's very simple. Suppose this is our position of prism and this is the incident ray. So this is the angle of incidence. If I change the position of the prism, then the angle of incidence that is made by the incident ray and the normal, obviously it will be changed. Now let me tell you about the position of minimum deviation. It is also very important. It might be asked to you. I'll explain it to you. I'll rub this part. So in this very first factor, these all conditions, they are much important for you. And the last and the important one in this particular factor only is about position of minimum deviation. Now, obviously, we cannot control the light ray, we cannot control the incident ray, we cannot change the path of the light ray or the incident ray, but we can change the position of the prism. So, I'll define it here. The position of prism, we can change the position of prism. So the position of prism with respect to what? With respect to the incident ray at which the angle of deviation or the deviation produced, I'll write it here, or deviation produced is minimum. So this position will be known as position of minimum deviation. So it's very simple. We cannot control the path of the light ray, the incident ray, but obviously we can change the position of the prism. So what is the position of minimum deviation? If you are asked about the position of minimum deviation, what is it? The position of the prism with respect to what? Because the path of incident ray cannot be changed. All of these positions of prism, we are talking about the position of prism with respect to the incident ray, at which the angle of deviation produced is minimum. Such a position of the prism is known as position of minimum deviation. So that was all about the first factor, that is about the angle of incidence. Now we move to the next factors that can affect, I'll rub this part. The second factor that can affect the angle of deviation is the angle of the prism. You know about angle of the prism, that is generally represented by angle A. So now we talk about the second factor, that is the second factor is angle of prism. It is denoted by angle A. So it is found that with the increase in angle A, that is the angle of prism, the angle of deviation also increases. If we increase the angle of the prism, then the angle of deviation will also increase. Now, the third factor, that is about the material of the prism, material or the nature of the prism, that is of which material is the prism made. Suppose we take example of two materials such as a flint glass or crown glass. Material of the prism means the material of which the prism is made. That is, we are talking about the refractive index of the prism. So, greater is the refractive index of the prism, that is of the material of which the prism is made, more will be the deviation produced. So, the third factor, that is about the material of the prism. Material of the prism or nature of the prism, we refer by noting this part by telling about the material of the prism. We mean that we are talking about the refractive index of the prism. Greater is the refractive index of the prism, more will be the deviation produced by the prism, produced by that particular prism. Suppose we have, you might be asked about this question in your examinations, it is frequently asked. Suppose we are provided a prism that is made up of flint glass, and the other prism, it is made up of crown glass. So the refractive index, let me tell you, the refractive index for this glass, for flint glass, it is greater than the refractive index of crown glass. So as I told you, greater is the refractive index of the prism, of the medium, more will be the deviation produced by it, produced by the prism. So the refractive index of the prism that is made up of flint glass, it is greater than the refractive index of the crown glass. So which prism will produce more deviation? Obviously this prism that is made up of flint glass. So I'll mention it here. Angle of deviation or the deviation produced by this prism, that is the prism made up of flint glass, will be greater than deviation produced by, suppose this is our, I'll clear it here, by flint glass prism, and this is our chrome glass prism. So you might be asked about it, that which prism will produce more deviation? This prism will produce more deviation. Why so? Because the refractive index of this prism, of this flint glass, is more than the refractive index of that crown glass. Now we move to the last factor, that is about the color or wavelength of light. You can do this part of your own because we have done it earlier in the last topics. Color or wavelength of light. Now as you know about the different colors of light starting from violet to red, the wavelength for violet color of light, it is minimum, and the wavelength for red color of light is maximum in any transparent medium. So the refractive index of any medium for the violet color of light, it will be maximum, and you know why. I have already explained it to you in the last videos. Refractive index of the same medium for red color of light, it will be minimum among these 7 colors of light: violet, indigo, blue, green, yellow and orange and red. So suppose that we have a prism that is made up of flint glass, crown glass or the regular glass. So if we have the same prism and one by one both these monochromatic light means, as the term sounds, I'll mention it here, monochromatic. This chromatic here, it stands for color of light, and mono means single. So if we take monochromatic light ray, such as for the first time we take the violet color of light and we allow the violet color of light to enter in the prism, then it is deviated. Then for the second time we take the red color of light and we allow this red color of light to strike the prism and enter inside it. Then in both the cases, what do we observe? That the refractive index of the same medium for violet color of light, it is maximum, it is greater. So as I told you in the last factor, greater is the refractive index, more will be the deviation produced. So if we talk about this prism, this is made up of ordinary glass, regular glass. So the deviation produced for the violet color of light, it will be maximum. Why? Because the refractive index of this prism is maximum for violet color of light. And if we talk about the deviation produced in the red light, it will be minimum. Why so? Because the refractive index of this prism, the same prism, it is minimum for red color of light. So the deviation produced in the red color of light, it will be minimum. So this was all about the factors affecting angle of deviation.